All right, so the accompanying data have a sample correlation coefficient rounded to 3 decimal places. Perform a hypothesis test with the data to determine the population correlation coefficient if the population correlation coefficient is less than 0 using an alpha of 0.01. So the first thing they want us to do is figure out our null or alternative hypotheses. So let's see. So we're doing this hypothesis test. I can't speak. Hypothesis test with the data to determine if the population correlation coefficient is less than 0. So that's what we're testing for, right? Is if it's less than 0. So that would be our alternative hypothesis that is less than 0. So I think it's our null is that it's greater than or equal to, and our alternative is less than. Fantastic. Thanks, Pearson. You really boost me up. All right. So the next thing we have to do is figure out the t-test statistic. So I'm going to come over here into the textbook and show you. There's a formula somewhere. So here's our formula for the t-test statistic. Can you see that? I don't know.
Yeah.
Okay,
I mean, my screen bigger.
Okay, it's like way on the bottom of my page. So, yeah. So it's r over the square root of 1 minus r squared over n minus 2. That's easy to remember, right?
Definitely.
A lot of times I'll use my snipping tool and like cut that out and put that over in my Excel just so I don't have to like keep switching back and forth or take a picture of it. Now you know the reason I let you guys use like notes, because I just think it's silly to memorize those formulas. I suppose if like you were a statistician and worked with that every day, you just memorize it out. You'd memorize it out of using it, right? But then there's certain things worth memorizing in the world, but that ain't one of them. All right, so I'm gonna bring up an Excel spreadsheet. So, you know, my way of kind of dealing with these things is to say like, okay, if I know that formula, t equals r over the square root of 1 minus r squared over n minus 2, then I can just like come over here and say, what do I know already? So I know it gives me, it says the accompanying data sample correlation coefficient, so that's r, of negative 0.773. So that's given to me. That was nice of them. And then I know n, which is the number of ordered pairs, right? So in this case, it's 1, 2, 3, 4, 5 is my n. And so if I know that all of that, then I can do my formula. So again, so my t-test statistic is going to equal r divided by the square root of 1 minus r squared, 1 minus r squared. There's the numerator over n minus 2. There's my t-test statistic. Negative 2.11. Thanks, predictive text. There we go. So, I mean, that one's as easy as like find the formula and do it, right? And then the p-value, p-value just means what's the probability of finding a point of that low or lower, right? And so this one is a negative 2.11. So I'm just going to do equals t dot dist, where my x is my t-test statistic. My degrees of freedom is n minus 2. Whenever you're doing regression models, instead of, you know how like in everything else, our degrees of freedom is n minus 1? But because we have 2 sets of variables for degrees of freedom here, we do n minus 2.
Oh, okay.
That's the rule. And true. There's my p-value. 0.06. What does it want? 3 decimal places? 0.063. And then here's the part where I always screw it up because I'm supposed to like talk myself through this, and it's like super easy to like get confused. All right, so state the conclusion. So we're gonna say, what are my choices here? So are we gonna reject the null hypothesis or not? So our test statistic is a negative 2.11, and then our p is a 0.06. So and our alpha is 0.01. So I think this means, let's see, our probability is 0.06. See, I always talk myself into circles on this, Tito. I have to like.
No, I know. I'm just like, you know what? I'm just gonna guess for this one, and I somehow get it right most of the time.
Right. Yeah. So I think as I see this, so if you remember our hypotheses, our hypothesis here is that it is greater. So our null hypothesis is that p is greater than or equal to 0. And then when we did our test statistic here, we found that our test statistic had a t-value of negative 2.11 and a probability of 0.06. And so I think that means that it is not as extreme as the alpha of 0.01. But I always get this confused. So there's let's just try it here. We're gonna not reject it because there's enough evidence to conclude, watch, it's gonna be wrong, is greater than. It's gonna be like, no, dummy. It's gonna be like, okay, how about we reject it? Because there is enough evidence to conclude that it is less than 0. Okay.
Nope.
Now we're like, oh crap, I'm on my final check. Okay, so let me think about this again. So we're checking the null hypothesis. So we're saying, okay, so we're going to reject the null hypothesis because there is not enough evidence to conclude that p is greater than 0. That's what I thought I put the first time. Okay, it doesn't like that. It says, do not reject is less than. So does that give you confidence that I don't know what the freak I'm talking about?
Just a little bit.
Yeah. I tell you, these always. So I do fine when we're just working with the test statistic, but when they put the p-value in there, that confuses me for some reason, and I always make a mistake. So when you go back to do it, at least you'll have the correct answer right there that you can use. What I usually have to do is, like, if I'm prepping for a test, is I have to like write out the scenarios and be like, okay, if it's this,
Yeah,
then I'm going to
that's
reject
what I
it.
do.
Because this is something I use so little in real life, which so little means never. That each year when I come back to it and I'm teaching the class, I'm like, wait, how does that logic work? I can figure out the answer, but I can't do their stupid hypothesis test. All right, let's look at the next one. Let me, oh wait, did I accidentally say similar problem? All right, so let's look at the next one. And we can come back and try to talk our way through that if we need to at the end, but let's get through these. Consider the following set of ordered pairs, and then calculate all this crap. Okay, so here's what I recommend. I don't know if, so when I'm gonna open it in Excel eventually.
Whenever I saw this problem, I was like, nope, I give up. And I emailed you. I was like, I need help.
Well, this one, if you use the regression tool in Excel, it makes life way easier.
Yes.
All
I
right,
like
so
an easy life.
you're all about the easy life. All right.
Yeah.
So in Excel, under data, I have this data analysis tool. If you don't have it in yours, it means you have to add it. It's an add-in. You go to File, and then you go down to the bottom and do
Oh.
options. I can show you how to do that. We did it earlier in the course.
Yeah, I
Anyway,
remember doing that.
so I'm going to choose regression for the analysis tool. I hit OK. Then it wants my Y range, so I'm just going to highlight these. And my X range, I'm going to highlight these. And then it wants my output range, and that's just where I want it to put this info. So I'm just going to say put it right there for now. It doesn't really matter. And it spits out this summary output. And so what's cool about this is once you understand what you're looking for, it does all this work for you. So it gives you right here under the coefficients, your intercept and your X variable. And so the intercept, if you remember when you were in high school or probably even middle school, they taught you or maybe even grade school, they taught you the formula for a straight line, y equals mx plus b,
Yep.
where m is the slope and b is the y-intercept. Remember that back in the day?
Yeah.
Um,
Yep. Back whenever I cried every night.
yeah, when you cried yourself to bed each night because that girl sitting next to you didn't like your hair. And then she saw you with quarantine hair and she was like, oh, yeah. FEMA's tough, right? Because there's only like 4 girls to even like, and 2 of them are your cousin. So,
Yeah. Hey,
but
it's okay. I'm adopted, so
you're right.
they're not
You're,
blood.
yeah, that's right. You could go out with your sister. I mean, so anyway.
No, my sisters are blood.
All right, sorry. Anyway, but so the way this is set up, instead of y equals mx plus b, the way they do it in this is y equals b plus mx. I don't know why, but that's what they do. So this x variable right here is always the one that goes next to the x. That helps for remembering. So if we do, so this is going to be y equals 5 plus 0.3 or negative 0.3x. So it's based on these two numbers here. The one that's labeled x variable is always the one that goes up against the x. Then it's going to ask you for all these things, your sum of squares. And this is given to you in this output right here under SS, which stands for sum of squares. Okay.
Sounds complicated.
So SST is your sum of squares total. So in this case, it's 2.75. This is way easier than trying to calculate each of these. And then they want the SSE and the SSR. And for whatever reason, just remember that the SSE is what they call residual. Okay, so it's this 2.3. And what they call SSR, the sum of square, they call regression, is what they call SSR. And that was it. That's the whole problem. So
Nice.
once you figure out how to use that what do you ever want to call it? The data analysis tool, it's pretty easy because it gives you the info. All right, so the third question is, as part of the research program for a new cholesterol drug, a pharmaceutical company would like to investigate the relationship between the ages and LDL, low density lipoprotein. The accompanying data set shows the ages and LDL cholesterol levels of 7 randomly selected men. Construct a 95% prediction interval to estimate the LDL cholesterol level of a 35-year-old man. Okay, so first thing we have to do, open our data set in Excel. All right. So there's our data set. And there's going to be some formulas to deal with here. So I'm going to go over to the e-text, go to section 14.4. And then I'm going to find that formula real quick. Or maybe not that quick. Let's see. So there's the standard error of the estimate, but we actually don't need that because I'm going to show you how to get Excel to give us the standard error. So this is at the confidence interval for an average value of Y based on X. Here, just to make our life easier, I'm going to snip this out and put it over in our Excel spreadsheet so we can see it. There we go. All right. So the way I try to deal with this, hold on. It was like, the way I always do these is just sort of like to take this, like, how do I put it? Take it in the order that I know it. So let's see everything I know here. I know, or what I'm going to need to know actually. So the formula is Y hat, and all Y hat, that's Y with the little hat on it, means is a predicted value of Y for a given value of X. Okay. So I'm going to call
Is
that.
it actually called a Y hat?
Yep. Yep. Critical T, that's the T of alpha over 2, right? Standard error. So I'm just working through the formula here. Y hat, T alpha divided by 2, standard error. And then I'm going to need N. And then I'm going to need X. And I'm going to need X bar. And I'm going to need the sum of X squared. And then I'm going to need the sum of X. So that's all the things I'm going to need to break down this formula. Does that make sense?
Yeah.
All right. So some of these are easier to get than others, okay? Critical T, I can get that just by doing t.inv.2t, because this is a two-tailed test. My probability is my alpha. So if it's a 95% prediction interval, then my alpha is 0.05. And my degrees of freedom is n minus 2, which is going to be this number. It's not going to work because
you don't have anything for N.
Right, but I will in a second. So N is just the number of ordered pairs, right? 1, 2, 3, 4, 5, 6, 7. 7.
Oh, I didn't see the age thing.
All right, and now my critical T is there for me too. X, it's going to tell me, it says construct an interval for a 35-year-old man. So since this is the X's and the Y's, X would be an age. So the value of X that's given me is 35. X bar is just the average or the mean of X. So take all my X values. There's my X bar. To find my sum of X squared, I need to add a column here that's X squared. And it equals X, whoops, not X, equals the X variable squared. Of course, my little thing's in the way here. All right. So the sum of X squared is just the sum of each of those values of X squared. And then the sum of X, same thing, we just take all the X's, get the sum of them. Now, I think the last two are the y-hat and the standard error. Those are a little bit harder. I'm gonna actually make this full screen so we can see all my tools. And like my Zoom stuff is like perfectly blocking the things I need to do. All right.
Yeah.
So right here, I'm gonna use the data analysis tool, regression. Let's see, for my Y range, I'm gonna highlight all of those Ys.
Is this for the white hat?
Both for the y-hat and the standard error.
Okay.
And then for my X range, and then where I want it to output, let's have it put it there for now. Whoops, it's being dumb. There we go. And it gives me that summary output. All right, so my standard error is given to me right here. Hey, Aaron, why must you argue with a 3-year-old? This is my son arguing with my granddaughter. She's saying what she wants to eat. He's telling her she doesn't want that. And she's getting annoyed. Hey, Elise, come here. Want to meet my student, Tito? Look. This is him right here. You see him?
Yeah.
Hi.
You can't hear him because I have headphones on, but say hi, Tito.
Hi, Tito.
Bye, Tito.
Hi, Tito.
Good luck with your statistics.
What with your thickness?
All right. All right. Anyway, and then y hat is just, it's us solving that straight line equation, y equals mx plus b, for this given value of x. So remember, the equation information is given to us right here. So if I say, so this is going to equal mx, so m is the intercept. So m times x plus wait, now I just got confused. I did that backward. Sorry. So remember, I always told you that this x variable is the one right next to the x, right? So
yeah.
So the x variable times x plus the intercept. Does that make sense?
Yes.
All right. So there's our, and again, what I always do is I double check and make sure it seems reasonable, because like remember, linear regression just plots a straight line to match these data points, these x's and y's. And so if we say, so here like 38 has a y value of 179 and 25 has a y value of 156, then would I guess that 35 has a y value somewhere around 172? Yeah, that seems to fit that data. That way I can make sure I didn't screw it up. That, like, you know, it's kind of like learning how to smell the milk and decide if you should drink it or not. This is like learning how to smell the numbers and be like, yeah, that seems probably right. All right.
Decent. I mean, a day or two after expiration.
Yeah, but I'm still good. All right. So here's all the data I need now to figure out this crazy formula. Some people like to just try to put this whole formula into a single thing. I think that's like the likelihood of making an error is high. So what I do is first thing I do is I like just break down this section into like a numerator and a denominator. Does that make sense?
Yeah.
Just this big fraction here. And then it's a lot easier. So the numerator of that fraction is x minus x bar squared. So if I just do like x minus x bar squared, there's my numerator. And then my denominator, this looks crazy, but it's not as hard as it looks, okay, is just the sum of x squared. Whoops, I have to do an equal sign first. Sum of x squared minus the sum of x squared over n. So then you could label these however you want, or like I said, some people like to just do the whole thing. I'm going to call it the fraction, but it doesn't matter what you call it, which is just the numerator over the denominator. And now I can figure out this whole part, this whole square root part, which is just this equals the square root of 1 over n plus the fraction, right, that I had figured out, that big crazy fraction. Actually, I should have put this whole thing in another set of parentheses. Whoops. And you could call that whatever you want, I don't know. So if you think about it, the formula is y hat plus or minus this whole thing. And this whole thing, some people would call it the error, which is the critical t times the standard error times this fraction that this radical that I just figured out. So I might just label it the error, or you call it whatever you want. But again, that's going to be the critical t times the standard error times this radical that I just figured out. And once you have that, then it's just y hat plus that and y hat minus that. So
Wow.
that's our upper prediction interval, or upper prediction level, is just going to equal y hat plus the error, and the lower prediction level is going to equal y hat minus it. I know it seems like a lot of steps and like it's super hard, but it's not as bad. We've done things like this already. It's mostly just finding all these variables, and once you find them, then you can work out the formula. It just is hard, and it's super easy to make mistakes because there's so many like moving parts to it, I guess would be a way to put it. Like a lot going on. All right. So upper prediction, let's see, 1 decimal place. So 196.5. And then lower is 148.5. And let's hope I didn't make a mistake in all of that. Oh, crap. Okay, let's figure out where we made a mistake. First of all, let's make sure I didn't just type something in wrong. 6.5, 148.5. So no such luck, as it was just that. Let's see. Critical T is 0.05. Our standard error was right here. Our N is 7. Our X is 35. Our X bar is the average, all those. Our sum of X squared. Sorry, this is all you can do when you make mistakes. Sum X, 232.
Yeah, it's just like go through everything.
All right, my numerator is X minus X squared, or X bar squared. So X minus X bar squared. That's right. Denominator is the sum of X squared minus the sum of X squared over N. So the fraction then is numerator divided by the denominator. Oh crap. Oh, what did I just do? And then that should be the square root of 1 over n plus the fraction. So the error should just be critical T times standard error times that. Okay, so I don't see what I did wrong. Which is crazy because I've done this lots of times and I don't know why it's wrong. Let me try it this way. Sometimes it didn't change anything. Sometimes it'll do some stupid rounding crap if you like carry out standard error, but that didn't change anything. N is 7, X is 35. I'm gonna see what the correct answer is. Oh, I'm way off somehow. The 238.4 and 106.7. Did I use? I'm wondering if I used like a weird. I'm gonna go back to this and make sure I didn't. That's for an average value of Y. That's the exact same formula. So, all right, Tito. Well, I'm sorry if I'm screwing you up here. I don't know what I did wrong, and I've done, like I said, I've done this many times before, and so I'm not seeing where the error is. C2 to C8 and A2 to A8. Should all be right, and X 35. X bar. Average A2 to A8. Sum of X squared. Sum of X. Minus X bar squared. Equals X minus, whoops, X minus X bar.
Your screen being shared?
What?
Is that your screen?
No. Buddy, one day you're gonna do all this.
You're gonna love it. And then our denominator is the sum of X squared. Minus sum of X squared. So I'm just reworking these variables to see
Yeah.
and see where I made a mistake. Oops. So that's the same. This is going to equal the numerator divided by the denominator. And then this is going to equal the square root of 1 over n plus so our error is going to equal critical t times standard error times that. And this is going to equal our y hat plus that. All right. All right, so I don't know what to tell you. I almost want to go back and look and see what I did when I did the video, because I got it right in the video, and I've, like I said, I've done it many times, and this is, I'm not sure. Let me make sure this isn't a two, am I calling it two-tailed? Let's see. Pretty sure it's two-tailed though. Yeah, that didn't change it. I'll see if changing it to a one-tailed test on the critical T. Nine, 7, 5. You know, I guess I'm gonna have to go back and figure this out and see if maybe I can record something for you, or because I don't, or did I restart this and we have weird data or something? Like 23, 143. No, that's the right data. Because I don't know what's going on with it. I don't know what I did wrong, and usually I can figure it out. I can be like, oh, that's what I did wrong, but right now I'm,
yeah, I know
and
there's a problem like that in the one other chapter that we worked on before our last meeting, and it was like something about like basketball games and stuff, and I was like, oh, this is an easy problem, and I did everything right, and I put all the right numbers in and stuff, and it came out like way off, and I was like, what the heck am I forgetting?
let's see. I'm like, did I choose the wrong stuff when I did my regression analysis? You know, I mean, there's like,
Yeah, so many.
that's why these ones are hard, is because it's easy to make a mistake, but I'm pretty sure I didn't on that part. So now I don't know what's data analysis, regression, B2 to B8, A2 to A8, output range.
This reminds me of accounting.
How's that?
Well, like in high school, whenever I was doing accounting and all that, I'd be working and I'd get through all like the different worksheets and stuff, and I'll find out that like one of my numbers was like way off, and I'll spend like the next hour and a half just like looking for one number that was like $2 off.
This times X. And then it's something dumb every time. You're like, oh, geez. Like,
Yeah, you're like, oh my gosh, missed it by 2 points.
and then our standard error equals, that's coming out to the same thing. I don't know. Critical T, standard error. So I've reworked this. So you know what I'm gonna do? I'm gonna have to just I'm gonna have to move on and send you a recording or something,
Yeah.
because I don't know. I'm sure it's something dumb, and like I said, I've
Yeah.
done, but like I would
This is, yeah.
I would
it's
swear this
just-
was right if I was like a swearing man. Let me try this real quick. Let us do this whole thing. Square root of 1 over n plus x. Whoops, I always type in x. X minus. Okay, dang it. X minus x bar squared is my numerator, divided by sum of x squared minus the sum of x squared over n that's what I have. I think what I had before. Like my teacher's stupid. Let's see, 196 to 148.
I was just like, wow, it's a problem that the great Mr. Fox doesn't know.
But I know I've done it, man. It's probably gonna be something dumb, like I'm using the formula wrong. Anyway, all right, so let's skip it, and then, like I said, we can. The other thing we could do is go to the guided problem. Guided problem. Don't get frustrated.
Never.
Oh, check it out. Look at this formula. It has this 1 plus 1 over n. Was I using the wrong? Did I like copy and paste the wrong formula? Is that the whole thing? Remember, because we just had 1 over n.
Yeah, but I thought you put the 1 plus in there.
No, I didn't. Pause. Let's go back to what we're doing here. And then, wait, hold on. Got too many things open now. All right, let's see. Wait a minute, what is this? See, look, it doesn't have the 1 plus that.
Yeah.
What the freak?
Is it just in a different?
Yeah, now I'm wondering if I like, or if I just, Okay, so this is a prediction interval for a specific value of y, but we had a specific value of x, right? Oh shoot, we're doing a confident. This is the confidence interval formula, and it was asking for a prediction interval. So that the difference is just this 1 plus in it, and everything else is the same. That's frustrating that we spent that long. So if I go back to this, let's see. So if I was just do 1 plus
Wow.
that was it.
That makes it that far off.
That's stupid. All right. So watch now. Like if we go and do a similar problem, I just type in all these variables: 24, 43, 38, 176, 26, 159. So I'm just updating the data. Oops.
I bet calculators like hate their job.
What's that?
I bet calculators like hate their job.
I don't think they have feelings at all. I'm not all about calculator rights.
I think they do. Like the T184 plus.
Yeah, it might. It's pretty close to sentient. Right, and then like, so the only thing else we'd have to change is the same number of n, standard error. Oh no, we'd have to redo all that too, but it would work for us. So anyway, so learn from my mistake, young Padawan, that if you're doing the prediction interval, don't use the confidence interval formula. Does that make? Maybe you'll remember it forever now. All right.
I'll just be +1. Just don't forget the 1 plus. Just put that in there. That's going to solve all my life's problems.
That's right. All right. And then, okay, the last one. Thank goodness. All right. I'm sorry that took so long. Consider the following set of ordered pairs. Assuming regression equation is yada, yada, yada. And the SSE
so is this kind of the same thing that we did?
No, of course not.
Or not at all?
That's silly. That would be silly. We need more crap to worry about. Anyway, we want, this one is construct a 90% confidence interval for the slope. And I'm trying to remember how to do that. Let's see. So we're going to go, this is 914.5. Make sure we get the right formula, because that helps. It really does.
Isn't that the one that we just used?
No.
The one for the confidence level?
No, because this is the confidence interval for the slope. So not, so it's, let's see. There's a t-test statistic for the regression slope, a standard error of the slope, confidence interval for the population slope. Let's see. I think that's going to be it. So in essence, we take a sample, we measure the slope of it, and then like how confident are we that the population slope is there. That's all that is. So we need this B1, which is the slope, plus or minus the critical T times the standard error of the slope. Okay, which sounds really hard, but if we go back to here, back to the homework. again, we can use our, oh, I have these Zoom tools in my way. Data. Oh, get out of the way. Data. Data analysis. Regression. Our Y range. Our X range. Our output. What's your problem? Oh, it's doing too much stuff. All right. So again, what was that formula now? I forgot that already. My brain is addled. So it was scroll. Okay. So the slope plus or minus the critical t times the error of the slope is what that all means. So we're going to need the slope, the critical t, and the error of the slope, error of slope. All right. So our slope is right there. Our critical t is going to be based on our confidence level, right? What was it? I don't know. That was a long time ago. Let's see. This thing's
90%.
Let's see. Our critical t is, sorry, it's the t alpha divided by 2, or we can do t dot inverse dot 2t. Put in our alpha, which is 0.1, and our degrees of freedom, which is n minus 2. And on this one is what, 6? So n minus 2 is 4. And then our error of our slope is given to us. Let me see if I can make this a little bit. So right here, where we see, here's our x variable, so there's our slope, right? So this number right here, the standard error of the slope, that's what we use. So that's our slope error. So once we have that, we can look back and say, okay, so it's the slope plus or minus the critical t times the error of the slope. So equals the slope plus this times this, and the slope minus. And whose baby's over there?
It's my nephew.
So let's see if I completely screwed this up. Negative 0.223. And the upper confidence limit is 0.536. All right. So I don't know how you're feeling. That's about all I can handle in one sitting. I don't know if I helped you or just confused you more. Like I said, sometimes actually me making a mistake and having to work through where I made it at might help, because in the end you're like, okay, I will never forget that stupid mistake. But that's not me trying to be like, I actually made that mistake, to help you.
Like, oh my goodness.
You're welcome. Like that. Anyway,
Oh,
so
you Gustav.
I'll send you a link to this recording, and you can work on it. And if you need to, if you need to, maybe send me like an email saying this is a specific one I need help with, so I can work through it, make sure I don't screw it up.
Alrighty.
You know what I'm saying? Like if you're going through the
Yes.
homework and you're like I don't know, I'm like really discouraged, even though I actually got 3 of the 4 right. Like first, it was just that
Yeah.
hypothesis one, and then this stupid one, the 1 plus prediction interval versus a confidence interval. Anyway, so why don't you try to work through that, and if you need help, let me know. I'm available. So we'll work it
Alrighty.
out. All right.
I know you're not doing anything else.
Yeah, I'm just doing jack squat. You know him. All right. All right.
See you
So I'll
later.
talk to you later. Bye.
All right.